upgrade time. Yep, today we want to upgrade the Orient Power, the Jaki battery, 11.7 kilowatt hours here. And I received an upgrade package for this battery because this here was one of the first. No, in fact, it was the first one they ever built of this series of batteries. And they sent it to me straight away to show here on the channel, which I did. And we were all very impressed with this battery. Guys, welcome back to the off-grid garage here in... Yeah. We have 71 amps outside at the moment. I'm charging the AO lithium battery back to 50%. And I have finished this wall. Everything is blasted, everything is sanded, everything is straight. So we can finally continue with the installation of the air conditioner. But this will be in a different video. What else? And this is pretty much everything which is happening right now in the off-grid garage. Today we want to have a look at the Orient Power, the OP48V230. It's a 48 volt, 230 ampere hours. Well, we always say 48 volt, but it's actually a 51.2 volt battery, right? This one is a pre-assembled battery, so it comes from the factory like this. It has a PACE BMS inside. And as I just mentioned, this was the first one they ever built of this series here. And shortly after my review, they actually changed some stuff inside this battery here because I wasn't quite happy with it. Cables were too thin. And months ago, they sent me the upgrade kit with the different parts. And today we want to put this one in and see if it makes actually a difference. So we've got two flexible bus bars here and a whole bunch of cables. Let's see. Two positive cables, 8mm ring lugs. This is 4 gauge wire. Silicon. And we've got two black cables, 4 gauge wire as well. 8mm on one side, 5mm on the other side. Alright, let's crack this case open and have a look. Alright, I've already removed all the screws around the lid and we just open up the case. Another more. No, here it goes. Wow, that is always a very nice view when you open a Jakiper and Orient Power battery. It looks so nice. This black, this shiny metal and the orange here of the bus bar looks so amazing, and look how beautiful this one is designed. It is well organized and is such a clean installation. I'm really a big fan of these batteries. And here at the front we can see the PACE BMS, and there's the communication board down there. We've got the bus bar here, bus bar over there, and there's a 250, is it a 250 amp circuit breaker? Yes, it is. It's a 250 amp circuit breaker. See, and what they did in this very first battery they ever built, they put like a 6 gauge wire, a single 6 gauge wire in here. And I think two 7 gauge wires for the negative coming from the BMS. And I wasn't quite happy with this selection of cables for a 250 amp circuit breaker. So they have actually upgraded the whole battery a long time ago with this set of cables and bus bars. I think we actually don't need the bus bars because we already have these ones. I'm sure this is the one coming from the BMS and going up to the main negative of the battery. Yeah, we don't need that. And this one here, I'm not a bus... Ah, that is the replacement. That is the bus bar for the circuit breaker. Okay, we have this already. So we only need to replace these cables actually. That should be very straightforward. Let's have a quick look at this BMS here. Menu, analog info, enter, down, 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 down. And we are on 72% state of charge. Perfect. And that's pretty much it. 53.24 volts. Okay, let's turn off the BMS. And we should have, yep, here it is. Oh, this comes with some electrical tape around it, so it doesn't disconnect accidentally. We turn off the positive to the BMS. And usually what I also do is here disconnecting this bridge here. This basically splits the battery in half, 24 volt, and takes away the 48 volt here at the main positive and negative of the battery. Yeah, just in case something happens, you don't have the 48 volt on these two terminals anymore. And as always, we are covering all the terminals we are not working on. and leave only these two exposed. All right, let's take these two off. Okay, next step is disconnecting main positive, main negative. And now we can take out the additional screws around the front plate. And we should be able to take out the whole front plate and replace these cables. This should give us access to the screw terminals at the BMS. I believe there are some screws on the underside of this front panel. Ah, shit! I can't really reach. Okay. Yes, they are. I had to put some timber under the battery here to give me access to these screws here, otherwise I haven't got enough clearance for a screwdriver. Where is it? Here. There are only 3 screws on the bottom. Alright, I have now put the battery in an upright position here. I thought this gives us maybe better access to the front plate. I'm disconnecting all the balance cables now. Okay, we take this one off. Alright, we should be free now. Oh yes, we are. That is the positive coming from the battery going into the circuit breaker before it goes here onto the main positive terminal of the whole battery. So this will be replaced with 2 of these ones to take out the circuit breaker as well, to get access to the screw here. Allen key. So we are replacing this 6-gauge wire with 2 4-gauge wires. That seems to be like a very good upgrade to me. The only question is, do we get 2 cables here in this terminal of the circuit breaker? Yes, we do. Yes. Alright, and then we can put the circuit breaker back in place. Put these long screws back in. I'm just hand tightening them. Now we want to pay attention here to this situation here where the cable needs to bend. It needs to go inside this frame here. Seems to be fine. Nice smooth bend. Because we don't want to end up with bended cables again. So, and the other upgrade are these cables going from here to the negative terminal up there. Very straightforward as well. Oh, oh. And here as well we're replacing 2 7-gauge wires with 2 4-gauge wires. All nice and flexible silicon cables. Beautiful, I like it. And these cables going under the PCB. Let's see that we don't disturb any of these thin cables here. Right, so this goes like this. And this one follows the other one. Yep, they are long enough. I thought they are a bit short, but yeah, this one actually doesn't need to go this way. It can go straight under the BMS, and there's enough slack in the cable anyway. So that's all good. I get a big screwdriver here, tighten them nicely. Check these ones here as well. Yep, they are all nice and tight. Now you may have seen in the battery here, they have actually used some color and marked off all the connections they have checked here with a torque wrench. So that's a beautiful detail you're not seeing very often with other batteries. And you can see the same here on the negative terminal as well as the positive terminal. They've got some color markers on there just to highlight they are checked. There's nothing on here though. Yeah, and here we can see the 200 amp big fat PACE BMS we have tested. It's a nice, very well built and very well designed BMS. We've got two inductors here. It's a 20 amp current limiter on this BMS. We've got the communication board down here, two small relays, and the MOSFET sitting all under this heatsink. And also the other side with the MOSFETs, there's no cooler. Isn't that bizarre? Doesn't need one apparently. I don't have any torque settings for these terminals here, so I'm just tighten them. I don't even think there are torque settings for these terminals. I was checking these ones here as well. Yep, they are all tight. Nice. Beautiful. Okay, this that's it. That's the whole upgrade we needed to do, because these flexible bus bars were already in place. This is the whole upgrade. By no means this is anything you need to do yourself when you buy such a battery. This is a fully pre-assembled battery ready to use, and it has these thicker cables and flexible bus bars already mounted. While we got the front plate out, we can actually have a look at the compression mechanic they have used here in this battery. So we've got a fairly thick compression plate here. It's angled at the top, which is very good, so it doesn't bend outwards. We've got this double support here welded onto it as well, which prevents it from bending. We've got big M8 screws here at the bottom holding it in place, and then have 6 smaller screws holding it against the frame here of the whole battery. This battery has no middle support in between the cells where the compression plate is screwed in. But yeah, that makes a very, very sturdy and high quality compression plate here. The overall build quality and impression of this battery is very, very good. Alright, let's assemble the front plate again. Let's see, so these are the positives to the terminal. Positive for the BMS, balance cables need to go in, and the negative from the battery to the BMS is already here as a flexible bus bar. Alright, I think we just drop it in. Actually, before we do that, it is a bit hard to reach these balance cable connectors, so I'm going to pull out the BMS like a little bit like so, and you've got these numbers here, so you can't actually do it any wrong. There's a number 1 here, number 3, number 4, number 2. And you can't actually do it wrong because these connectors have a different amount of pins. So starting with number 1, it is a 7-pin connector, and number 2 is only a 6-pin connector. Number 3 is a 7 again, and the last one is a 6-pin connector. So the number 1 does not fit on this side of the PCB, it only fits on this side. Number 1. Number 2 is the 6-pin. Number 3 is a bigger one, 7-pin. And number 4 goes in here. And all these connections here, they are actually secured with these silicone glue, so they don't loosen during transport or later on down the track. This won't come out without you pulling really hard on these cables here or removing this glue. Now we are dropping it in, connecting here the main negative first. And interestingly, these, I think they are EVE cells, they come with M8 terminals. Look at this, M8 aluminium terminals welded onto these original flat terminals of the batteries. Pretty cool. Okay, and now the positive cables. One here, one there. Positive on top, and there was another cable just right over here. That's the positive power supply for the BMS. Okay, let me pre-tighten them first so they're not coming off. And then I'll put the screws back in for the front plate and lay the battery flat back on the trolley. And we just have 250 amps outside. Sun just came out. Crazy! It's just for a short moment anyway, so doesn't matter. Alright, and in the last and final step we want to build a 48 volt battery again. We put this bus bar here in place. Balance cable for cell number 8. 2 flange nuts. Pre-tighten this all. So I'm going to use 4 Newton meters for all these battery connections. Therefore the main negative and positive as well. 4 Newton meters, that's all I do. And yes, if you still haven't got one, I linked this digital torque meter down under the video in the description. And also this adapter goes from a 1/4 inch socket to 1/2 inch socket. So we can actually use, where is it? Here. Can actually use these larger ratchet sockets. Okay, 4 Newton meters. That's it. That's it here. And these two at the end here as well, 4 Newton meters. Yep, cool. Ta-da! It really looks nice, doesn't it? Huh? Come on. The design is really nice. I like these colors here with the chrome and the orange and black. Everything is numbered. Alright, and last and final step, we want to connect the positive of the battery with the positive of the BMS. Plug this all in. I can see the display already turning on. I use this bit of electrical tape here to secure this connection, so it doesn't come apart. But we leave this here for easy access in case we need to turn off the BMS. We have to disconnect this cable here. So, and now we turn it on. And 53.25 volts, nothing has changed, of course. Let's have a very quick look at this BMS here on the computer software, because I want to show you how well organized this BMS and the computer software is. So before I close the lid here, I want to show you how nice and long these new cables are now. The old ones were fine as well, it's the same length basically. They are bending in a nice, smooth way here. Because some other batteries we have seen in the past, you know, we have tested here on the channel, they have really short cables because they're trying to save on copper or so. And sometimes it really makes them bend hard. But these ones here are perfect and nice and long. So they're really out of the way of everything else. This is what I want to see in all batteries. Alright, we now have a 4-gauge wire, two 4-gauge wires in this battery. 4-gauge wire is 21.1 square millimeter times 2 makes 42.2 square millimeter. So looking in the table for silicon cables here, we don't have a 42 square millimeter cable, we've got a 35 or a 50. It's larger than a 35, it's smaller than a 50. So somewhere in between. One or more single core cables laid in duct. Multi-core cable, flexible and open ventilated conduct. No. Single core cables laid in open air with spacing of least. Well, we are definitely not in open air. Yeah, it is in a closed compartment of the battery. So I would say it is group 1. One or more single core cables laid in duct. Yeah, we've got an enclosure around the cables, so there's no actual airflow. The last group here more implies the cables are in open air, which is not the case here. We can use a fuse of 100 to 125 amps for this 42.2 square millimeter cable, but we have a 250 amp breaker in this circuit. Yeah, and even if we are very, very generous and go to group number 3 and have a look here at 50 square millimeter, which we don't have, it is recommended to have a 200 amp fuse for these silicon cables there, not a 250. So the cables are still a bit too thin. And then when you imagine you've got double terminals here, so this is actually designed for stacking multiple of these batteries up and then connect one battery to the next one, to the next one, to the next one, yeah? And with every battery you're adding 250 amp of breaker capacity. So 250, 500, 750, and 4 batteries are 1000 amps. So you need to have a connection cable to these 4 batteries then, which is rated for 1000 amps. So with these pre-assembled batteries, I'm always recommending get an external fuse or breaker for each of your batteries. Don't rely on the 250 or 200 amp circuit breaker which comes with the battery. Yeah, you can see the internal cables as well as the external cables you probably put in are not rated for these high currents. None of the batteries we have ever tested had actually the appropriate cables for the used circuit breaker installed. So if you want to check on your battery, I link these documents down under this video here as well. This is what I usually use, gives you a bit of a rough idea what is going on in your battery, what kind of cables you are using. what kind of current your cables can withstand. Okay, let's have a look at the BMS. And I think the Jaki battery is the only battery where we actually use an RS232 cable, and I think the batteries are coming with this USB to RS232 adapter, and then it goes onto this 9-pin, geez, what's this connection called here? Geez, what's this connector called? It's like a serial, it's like an old computer serial port. I put it here on the screen. And here on the other side is just a clear RJ11. And this plugs in to the middle port of all the 5 RS232. Bam! We've got the dip switches set on 1. Alright, and then we want to start the PBMS tool 2.5. Here we go. We are on COM9. Click on open. And there we go. We are connected to the battery. Gives us the overall voltage here. Remaining capacity, full capacity, all the cell voltages. We've got 2 millivolt deviation, but we are in the actual flat area of the curve, so doesn't really matter. Ah, this is the wrong software. It doesn't have any more tabs here. Hang on. We have to open the BMS tool 2.03. There might be a newer version already. Yeah, this one has all the tabs. And COM9, we open this one. Should get the same information. Yep, here they are. And we want to have a look at the parameter settings. And look how well they are organized. They are in little groups. They've got a little frame around it. You can easily see these are all my cell over voltage settings. These are my PAC over voltage settings. Cell under voltage, PAC under voltage. How good is this organized in this software? How easy is that to make sense out of it, right? The balanced start voltage, the balanced deviation, everything is close together, which belongs together. All right, let's do a read all. Let's see what parameters we have. And it reads now all the information from the BMS into the software. And there we go. And here I want to show you again the PAC full charge voltage. Yeah, we set this one to 55.2 volts. And we also have a PAC full charge current. Once we reach the 55.2 volts, the current obviously decreases because the cells are absorbing and taking less and less power. And once the current is going under 2 amps, the battery is considered as fully charged. The BMS resets to 100%. But the BMS still allows your charger to supply power to all your load. The battery just stops charging at this point of time. It is a shame they have never developed a PAC float voltage here. So it should be fairly easy for PACE to actually implement these new features, to have a full charge algorithm in this BMS here as well. It would still lack other features in regards to the Jaki BMS. For example, the active balancer, of course. This one has only a passive balancing here with 150 milliamps or something. And it also doesn't have the functionality to program these 2 little relays, these contactors on the PCB. As you know, this is all possible in the Jaki BMS, and we can freely program these little relays to overvoltage, overcurrent, alarms, protections, temperatures, everything we want basically. So the PACE BMS is really good. It's a very nice BMS and easy to set parameters here, but it lacks some key features which the Jaki BMS already have as hardware, like the active balancer, as well as here in the software. But apart from that, very good BMS here. I really like the PACE BMS. Alright my friends, I think this concludes the video from today, upgrading this battery here with the appropriate cable. At least this is what you will get when you buy such a battery here. Buy such a battery. I've totally forgotten about this. Orient Power, the guys from Jaki Battery, are so kind to give you some discount codes for these batteries here. Unfortunately, only in Australia at the moment, but you can get a 20% off discount on this battery here. It's a 48 volt or 51 volt and almost 12 kilowatt hours of capacity, 20% off. But only for 2 orders, and then it drops down to 10%, and there are like 20 orders with 10% off, and then it goes back to the usual 8% you will always get on my channel here for the Jakiper battery. So have a look down in the description of this video here. I linked all the information down there. It's also on my website. So if you are in Australia here and want to place a big order with these batteries, they've got them in stock in a warehouse in New South Wales. Takes probably a week only to deliver them, and you pay only 1 flat fee for shipping with a 20% off this battery. could be a very interesting deal. Subscriber. Oh, I need to change only 2 numbers. 5. Oh, one of the little magnets came out. 27. Thank you so much for 104,527 subscribers. Totally mad. Alright, my friends, as always, thank you so much for watching. Thanks for all your amazing support here, keeping this channel running. Thanks for all the beer donations. I really appreciate them because we are still in the middle of summer here. We've got like 35 degrees every single day, and I'm calibrating a very ice cold spat every afternoon. And in one of the next videos, we want to have a look at the split air condition we want to put in this room here. But we want to upgrade this device here with a new feature and function which we will need here in the battery room. Yeah, and then we need to make a decision with the outside unit, but this will be in a separate video as well. So there's more to come, more to decide, and more to do, of course. Yeah, don't you worry. The videos won't end soon. Alright, my friends, until the next video, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye. The good old Jaki battery. Nice one.